Continuing on with Unit 4 in this video, and this video is going to focus on learning target 6C, which is all about solving radical equations. By the end of this lesson, you will be able to solve any equation with a radical or rational exponents. So let's jump right into some examples here. So for all of these, we're going to solve the following for x, and in our first equation, we have the square root of 3x plus 4 plus 1 equals 7. And in all of these equations, we're either going to see a radical, so maybe a square root, a cube root, maybe even a fourth root, or we might see a rational exponent of maybe a 1/2 power, or a 1/3 power, or maybe even a 1/4 power. So in our first example here, our goal is to be able to isolate the x. And since the x is stuck inside the radical, I need to figure out how to get rid of that square root. So my first goal before I can actually get the x by itself is to first isolate the square root. So to isolate the square root here, I'm going to want to subtract the 1 from the other side. So we get the square root of 3x plus 4 equals 6. And now I have my square root term isolated. Now that that square root term is isolated, what could we do to the left-hand side to get rid of that square root? Well, if we square the left-hand side, we know that the square root and the square cancel each other out, and we would just get left with 3x plus 4, which is our radicand. But whatever I do to one side, I have to do to the other side to keep the equation balanced. And so since I'm going to go ahead and square the left, I also have to square the right. 6 squared would be equal to 36 then. Now from here that I've gotten rid of the square root sign, I'm going to go ahead and solve this just like I would any other equation. So we're going to subtract the 4 to the other side and then divide through by 3. And we were able to get x to be equal to 32 over 3 then. Let's look at our next example. So in example 2, we have 4 plus the square root of x minus 5 equals 8. What do you guys think our first step is going to be to solve example 2? So our first goal is to be able to get that square root by itself, so I need to go ahead and subtract 4 to the other side. So we get the square root of x minus 5 equals 4, since the 8 minus 4 will give us 4. Now from here, what could I do to get rid of that square root? So to get rid of the square root, I can square it just like we did before. And whatever I do to one side, I have to do the other, so I have to square the 4 as well. And then on the left side, the square and the square root cancel, so we're left with x minus 5. And on the right side, if we simplify 4 squared, we'll end up with 16. From here, to solve and get x by itself, if I add the 5 over, I end up getting x is equal to 21. Let's look at our third example. So here it looks a little bit different. We have x plus 12 to the 1/2 power minus 5 equals negative 3. Well, what does the 1/2 power represent? Well, the 1/2 power is the same thing as the square root. We learned earlier in this section that if I have the nth root of something, that's the same thing as that number, let's say x, to the 1 over n power. So since I have the 1 over 2 power, 2 is our index, which means that we have a square root. So these are actually the same thing as what we did up in examples 1 and 2. Why don't you guys pause the video here and solve example 3 on your own, and then we'll check it together. So our first step to solve example 3, I want to move that 5 to the other side so that I can get the stuff that's to the 1/2 by itself. So I'm going to add 5 to the other side, and we'll end up getting a positive 2. And from here, I want to do the same thing that we were doing before. If I square that left-hand side, the squared power and the 1/2 will get multiplied, and I would just get left with x plus 12 to the first, which is the same thing as x plus 12. But whatever we do to one side, we have to do the other to keep our equation balanced. So we end up getting 2 squared on the left, which would be equal to 4. From here, to get x by itself, we're going to isolate x by subtracting 12, and we end up getting x equals negative 8 then. So in these first couple examples, we can see how we can maybe have some square roots, which would be our radicals, or we could have these rational exponents with these fractions, such as 1/2. Let's look at example 4. So in example 4 here, we end up with the cubed root this time of x plus 5 plus 1 equals 3. So this is going to be a little bit different just because we have a cubed root. But our process as we're going through them is still going to be the same. Our goal is to isolate the term with the radical. So to do that, I need to go ahead and subtract the 1 to the other side. So we end up with the cubed root of x plus 5 equals 2. And from here, what we were doing before is we were squaring both sides because the square root and the squared cancel. Well, I can't square this, that won't make the cubed root go away, but what could I raise the left-hand side to that would cancel out with the cubed root? Well, if I cube the cube root, then they would go ahead and cancel because the cubed root of something is equal, so let's say the cubed root of x is equal to x to the 1/3 power. So if I multiply by 3, then the 1/3 and the 3 get multiplied and we end up with just the first power. Just like we did before though, whatever I do to one side, I have to do the other. So if I'm going to cube the left, I also have to cube the right-hand side. On the left-hand side, we just get left with the x plus 5 since the cubed root and the cube cancel. And then on the right-hand side, if we simplify down 2 cubed, we would end up with 8. From here, to isolate x and get x by itself, we're going to go ahead and subtract 5, and we end up getting, x is equal to positive 3 as our final answer then. Alright, let's look at our fourth example. So here we have, or our fifth example, here we have 7x minus 2 all to the 1/3 power plus 4 equals 5. Why don't you guys pause the video here and solve this example on your own first, and then we'll check it together. So our first thing on this one that we're going to want to do is we want to isolate that 7x minus 2 to the 1/3. So we're going to go ahead and subtract the 4. So we end up getting just a 1 on the right-hand side then. And this is similar to that cube root that we had up above in example 4. Instead of it being written as a cube root though, it's just written as the 1/3 power, but we know that those are equivalent. So if I cube the left-hand side then, the 1/3 and the 3 would cancel each other out. But whatever I do to one side, I have to do to the other since I have to keep my equation balanced. So on the left side, the cube and the 1/3 power and the cube cancel, so we get 7x minus 2. And then on the right side, 1 cubed though would still leave us with 1 in this case. And from here we can go ahead and isolate x by adding 2 to both sides. So we get 7x equals 3. And then to divide through by the 7 to get x by itself, we end up getting x equal to 3/7. And that will be our final answer. Let's look at one more example here. So here we have a 4th root of 9 minus x plus 8 equals 10. And we want to go ahead and solve this for x. So this one's going to be a little bit different since we have a 4th root now, but we've done this already with a square root and a cube root, and we see how they've worked out very similar to each other. It just depends on what we end up raising each side to. So why don't you guys pause the video and think about how you would go ahead and solve this. Why don't you guys try solving it and then we'll check it together. So our first step here, just like we've been doing, is I want to get that radical by itself. So I'm going to go ahead and subtract over the 8 to the other side. So I end up getting the 4th root of 9 minus x equals 2 then. And now this is what makes this problem different. I don't have a square root, so I'm not going to square it. And I don't have a cube root, so I'm not going to cube it. Now that I have a 4th root, I'm going to go ahead and raise it to the 4th power. And whatever I do to one side, I still have to do the other. And I want to remind us the reason that's working out is because the 4th root of x would be the same thing as x to the 1/4 power. And if I multiply 1/4 by 4, I would end up just getting an exponent of 1. So the 4th root and the 4 do cancel each other out, and we get left with 9 minus x on the left. On the right side, when we simplify down 2 to the 4th, we would end up getting 16. Now to get x by itself, I want to subtract the 9 over, and then divide through by the -1 since my goal is to get x by itself, and I end up with x equals -7 then as our final answer. So we've seen through these 6 examples that although I had different indexes in each one of them, I am still using kind of the same process as we go through each one of these of isolating the radical term or isolating the term with that rational exponent, that fractional exponent. Then from there, trying to figure out, well, what could I raise that side to that would get rid of that exponent power or would get rid of that radical. And then remember, whatever we raise it to on the left-hand side, we also have to raise to on the right-hand side to keep the equation balanced. And then from there we can go ahead and solve it similar to how we would have solved any other equation involving x.